Okay, so this next part, what we're going to talk about, I have to admit, is a little bit tricky. It will require some serious focus, and it's something I was never shown in school. But after having seen this, what I'm about to show you, I have to say my mind was fairly blown. So just for some anticipation, I want to show you what we have. We have one-dimensional motion. We have a mass moving back and forth in a straight line on a spring. I don't see any right triangles here, do you? I don't think so. Yet what we're going to get pretty soon is an entirely new way of looking at trigonometry, the science of right triangles. This graph is a graph of position versus velocity. So on the x-axis here, we have position, and I've divided by x max, the maximum possible position. So if I were to put a dot here, that would mean that at some point in time, the mass was all the way at the maximum possible position. That's why this number is 1. And notice that I've put it here. I didn't put the dot here or here. And that's because on the vertical axis, I have velocity. Here, velocity can be as much as positive Vmax, which we calculated earlier, or negative Vmax. Positive this way, negative that way. But we know that for the instant when the block is over here, its velocity is equal to 0. It stops for that instant before it gets pulled back towards equilibrium. Okay, so this is a point on our graph of position versus velocity. Let's see if we can fill out some more points. I promise you we are going to see something very interesting. I've given you 4 possible suggestions for points that should exist on this graph. Can you select the appropriate one?